This video is on the topic of diamond and graphite. An allotrope refers to one or more forms of a chemical element, and due to the differences in bonding arrangements, they are physically completely different. Diamond is an example of an allotrope of carbon and is also a giant covalent structure. As you have learnt in this topic, diamond contains strong covalent bonds throughout the structure. Carbon can form up to 4 bonds. Each carbon in diamond is bonded to 4 other carbon atoms, meaning there are no free electrons in the structure. Therefore, diamond has a high melting point, does not conduct electricity, and is hard. This means diamond can be used for jewellery, drilling, cutting, engraving, and cutting edges in scalpels. Another giant covalent structure is graphite, and it is also an allotrope of carbon. Each carbon atom is bonded by strong covalent bonds to 3 others forming layers of hexagons. This means that there is one electron which is delocalized and exists between the layers. Within the layers, the covalent bonds are very strong, but between the layers, there are weak intermolecular forces of attraction. Therefore, graphite conducts electricity, has a high melting point, and is soft and slippery. This means that graphite is perfect to be used for electrodes in electrolysis and for pencils. Let's have a look at some example exam questions. Here, you are asked to explain why diamond is a very hard material for 2 marks. Whenever you are asked about the properties of a substance, the first thing to do is to identify the type of structure that you are being asked about. Diamond has a giant covalent structure. Alternatively, you could say carbon atoms are bonded to 4 others. This scores the first mark. For the second mark, you need to make the point that these bonds are very strong, which will take a lot of energy to break. You could also be asked to compare the structure of diamond to graphite. In diamond, each carbon is bonded to 4 others, whereas in graphite, each carbon is bonded to only 3, resulting in different properties, such as a lower melting point. It is important to know the uses for allotropes of carbon, so make sure you learn at least 2 for each one. So for part B, you have options to gain the mark. Remember, covalent bonds are very strong, so a lot of energy is needed to break them. This example is about graphite. In this question, you are asked why graphite can conduct electricity for 3 marks. In this giant covalent structure, carbon atoms are bonded to 3 others for the first mark. Or you could say carbon atoms form 3 bonds instead of 4. Remember, this means that there will be 1 spare electron. For the second mark, you must state that there is 1 delocalized electron, which will come from each carbon atom. You must make the point that there is 1 electron not involved in the bonding. For the final mark, you need to talk about the delocalized electrons, which are between the layers. They are able to move and carry a charge. This is important to state, as it is the current moving through the structure. When answering questions about diamond and graphite, it is always good practice to state the number of covalent bonds each carbon has, and this will remind you about saying if there are any free electrons. In summary, diamond and graphite are allotropes of carbon. Diamond contains strong covalent bonds, and each carbon atom is bonded to 4 others, and there are no free electrons. This means diamond has a high melting point, is hard, and does not conduct electricity. Graphite is made up of layers. There are strong covalent bonds within the layers, but weak intermolecular forces between the layers. Each carbon atom is bonded to 3 others, meaning there is 1 delocalized electron for each carbon. This means graphite has a high melting point, conducts electricity, and is slippery. Don't forget to check out all our other fantastic revision resources here at Save My Exams.